hope you enjoyed yesterday gala dinner, as I enjoyed. Today, I'm going to talk about threat modeling. But first, I want to ask you a question. Hopefully, I will be able to see the answer. How many of you ever heard about threat modeling? OK. How many of you tried to do threat modeling during your daily job in ICS? OK, that was somewhat expected. That's why I'm here today, to talk about threat modeling. I know most of you will think, what a word is like, machine learning, artificial intelligence. It's not very defined. Yes, in ICS it's true. We'll see later. I gather some statistics about how is the state of art of threat modeling in ICS. Though, since I'm part of a product security team, so for a company that does software also for ICS industry, I have to deal every day with customers that have security requirements, safety requirements, nuclear plant, and so on. So we are doing threat modeling from application security point of view. But 4 years ago, when I joined the company within the product security team, before joining, I had the same reaction of most of you. Why exist threat modeling? What it is? I'm an offensive guy, technical guy. I break things for a living, right? So for me, the most practical way to demonstrate a vulnerability is to find it, right, and exploit it. So threat modeling, we'll see later, is an earlier stage in the software development lifecycle. And from now on, I will mention the software development lifecycle as SDLC, just to keep it short, since I have not much time. And the point is that threat modeling has different benefits. But first, going deep dive into threat modeling, what it is, how the process it works, methodologies used, and so on, how can benefit ICS industry, I want to discuss a bit more about three terms. Three terms that are daily used in the security world, and sometimes are mistakenly used as synonyms of each other. The terms are vulnerability, threat, and risk. So I brought here a very practical example. Imagine you are in your lovely cottage in the middle of the forest, enjoying the last days of summer, and suddenly a bear appears in front of your door. What's the first thing your wife will probably scream at you? Close the open door to keep out the bear, otherwise we are screwed. So in this case, it's very practical approach to understand the three different terms. The open door is the vulnerability, of course. The bear, in this case, is the threat or threat actor. And otherwise we are screwed is the risk, right? As yesterday Patrick said, IT people are very bad to communicate with executive and management about security, right? We focus on technical things. They care about risks. So security is part of the risk. So it's part of the game. But they don't care specifically about security per se. So we need to perfectly understand the differences between these three terms that can perfectly fit in one sentence, though they have different meanings, different semantic. And this is the most important part. Understanding them leads you to a successful risk analysis, and we'll see later also to a successful threat modeling. This is probably most of you will recognize the image is the so-called Purdy model. We will see later what it is, but this slide is just, I just put it in the slide deck to reflect for a second about the entry points. Everyone knows that an enterprise network, like a bank, has a certain amount of entry points. In ICS, we multiply them by different levels, right? Because we don't have anymore only the enterprise network, but we have other levels, like different appliances at different level. We'll see later again the Purdy model. But that's a fact. There are many entry points and different. One interesting fact I realized is that most of the attack in ICS can still be correlated to the application security world, right? Because PLC are running firmwares, they have HMIs, they have interfaces, they have text boxes, and so on. So this is an example from a Dell report of 2015, and this pie chart is pretty much explanatory. So according to this report, the key SCADA attack methods were related with OPSEC. So it can be like improper input validation, cryptographic issues, path traversal, SQL injection, command injection, and so on. So what's the most important part of that? Well, if we go back to the previous slide, all those attacks can be related to the OWASP top 10 or SANS top 25, which means that they are well documented in the AppSec world, right? The software development industry. And we already have recommended mitigation in place. And we can do threat model. We are doing threat modeling in AppSec extensively. When I joined the company, besides joining the product security team, I joined the threat modeling task force, which is composed of attackers, defenders, and security architects. And this team was meeting with each dev team to do threat modeling of their product. And at the beginning, I was a bit suspicious about that. But then I started doing threat model again and again. I started to see a fact that we are able to find threats and catch many vulnerabilities earlier in the design phase. How it works, the software development lifecycle. It's composed of few steps there in green. There are definition of requirements, design, so architectural review or design, development, testing, and deployment. 15 years ago, software development companies like Microsoft realized that is not enough from security point of view. We need to add something, some action items to each of those steps to bring security into software development. Nowadays, look at IoT. Where is the S there? There is no S for security in IoT, and that's a problem. So not all industries already caught up the fact that security must be mandatory in a development life cycle. Let's take the hardware development life cycle, which is another talk, another story. Now let's focus on threat modeling. Where is applied threat modeling in a secure SDLC? At the design phase. Of course, in the ICS industry, the speed of plant development is way longer than a classic product software development. A new release can come up in 6 months, 3 weeks, depending on if they are agile or not, the dev team. In an ICS plant, unless you are renovating it, it will take years. We know that, for example, the metallurgic industry has plants that are 50 years old that are still doing fine. So that's a problem. We cannot fully apply threat modeling on the design phase of ICS plant, unless we start now doing threat modeling for the next upcoming plants or innovation plans. But still, we will see we can do threat modeling afterwards. But still, the most valuable phase where we do threat modeling in software development lifecycle is at the design phase. We will see later, will pay off. This is 3 reasons usually we use in AppSec to motivate executives to allocate resources and time. First of all, it produces measurable data. So the number of threats and associated risk can be seen on a report, so are definitely a tangible thing. It smooths the path to compliance. It makes happy auditors, right? Many customers are asking us, do you do threat model? At the beginning, they were asking, do you do, dynamic testing? Yes. Do you do static code analysis? Yes. Recently, they're even asking, do you do threat model? So we need to cope with that needs of the customers as well. And of course, to make happy CEO, CFO, shareholders, it saves money. It's proved, this is one research from 2010, that if you apply threat modeling at design phase, it costs way less than doing threat modeling later, or even fixing vulnerability due after a pen test or a security scan. How it works, threat modeling. This can be easily applied to AppSec and also ICS, some sort. We'll see which part can be tweaked. What we do for doing threat modeling? Well, we create assets inventory. We have nowadays solutions in the market that can do assets inventory for you. Otherwise, you can go and knock the door of the network operations center or any network engineer to find even more from Excel spreadsheet. Anyway, you get assets inventory. You create an architectural model. Like we'll see later, we can use the Purdue model in ICS. In AppSec, we use DFD, data flow diagram, to create a model of all entities, like imagine browser, front end, back end, databases, and so on. And then we decompose, again, now that we have boundaries and interconnections between each asset, we analyze each single asset and look for threats. As I said before, most of the threats, vulnerabilities that can be correlated to specific threats are coming from AppSec, so we can reuse them. And actually, some of you most likely is using them. We will see which tools actually you're using. After you find threats, you document them. There are tools that automatically report most of the threats and present you with mitigations. And then you rate them. So now we need two methodologies. We need a methodology to categorize threats, and we need a methodology to rate them from sort of risk perspective, right? Because risk is the most important thing from management point of view. That's how they make decisions, depending on, beside the mitigations you provide for each threat. So what we use as methodology in AppSec for categorizing threats is called STRIDE. It was invented in 1999, used by Microsoft since 2002. It's the most mature, so far, methodology for defining, categorizing threats. And is using data flow diagrams, as I said. We will see later a tool by Microsoft, created by Microsoft, that is using this technology to create a threat model. And then we categorize threats. STRIDE is yet another acronym, because we are IT, OT people, we love acronyms, and stands for different threats. Spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. Each of those threats is violating a specific property, security property. We know the CIA paradigm, confidentiality, integrity, and availability, can be extended to other properties, like, let's say, tampering. Tampering is violating the integrity property. Imagine a man-in-the-middle attack in a network, a packet gets modified, like, for example, a Modbus UDP packet. There is no encryption, no mutual authentication, is even stateless because it's UDP. So a threat actor can potentially modify it, right? So we can take that Modbus UDP appliance, that appliance communicating Modbus UDP, and create a threat. Tampering. And for tampering, we have a set of mitigations, of course. But we can do better. As I said at the beginning, what I'm doing here with this presentation is try to convince you that we can, some of you are already doing that, but we can improve that. Take the threat modeling from AppSec and bring it to ICS. So in this case, in ICS, beside those threats, we may have more. Two more that came to my mind very obviously are physical DOS and physical harm. The physical DOS is violating the resilience property. As you know, if some of you is working, for example, in the nuclear industry, resilience and safety are the most important things out there, besides producing energy, of course. The second one is physical harm, which is violating safety. So to give you an idea, for example, if the safety property is violated, is like the idea of undermining ICS safety controls in order to cause physical harm. Hopefully for us, it shouldn't happen, but still we need to consider that. That's why we do threat model. And that's why sometimes there are attacks that were unexpected because were not included in your threat model. So now we have a way to categorize threats from AppSec to ICS. Now we need a way to rate them, from prioritization and risk point of view. In AppSec, we are using DREAD, another acronym that stands for damage, reproducibility, exploitability, affected user, discoverability. Though we can still tweak it to fit more the ICS word, which is another risk that is very important for ICS and doesn't matter in banking environment. Well, environmental impact. You can call it as you want. The idea is that how many living casualties there will be in case this threat happen. In this way, now we have a methodology to find threats, categorize threats, to rate them from priority point of view. We need a model, which is the easiest, the most logical conclusion in ICS for a model, beside your 3D design plant that was designed by your CAD engineers. The Purdy model. Most of you, how many of you know about the Purdy model? Okay, bunch. By the way, the same guy that was doing threat modeling. Cool. Okay, so the Purdy model is a reference model of enterprise architecture developed in the 90s, and recently was adopted by ISA 99 and tweaked by Rockwell and Cisco to fit the ICS world more properly. So in this way, we have from 0 to 5 level. OK, doesn't matter. I cannot show you the pointer. The point is that there are from 0 to 5 levels. The 0 level is the physical process, where actuators, sensors, the parts of a plant as close as possible to the physical world, right? So like, for example, from an ISO-OSI perspective is the physical layer, like, the physical wire. Then we have level 1, where we have PLCs, for example, level 2, where we have HMIs, and so on, until we reach the classic enterprise network of ICS infrastructure. So now we have a model. Why is it good to use this kind of division? Because you can, depending on even on the risk analysis you have done, you can decide where to start threat modeling. You don't need to do threat modeling in the whole infrastructure, and we see later can get very messy with Microsoft threat modeling tool, for example. But you can start from the level you prefer. Like, if you feel comfortable and confident that no one will, or is less likely that some contractor will plug in a malicious USB device or a USB implant on the level 2, like HMIs, you can start from enterprise and vice versa. So now we have a model. We have 2 methodologies. So what's the problem? So I was looking around. I created a survey. And I realized that the situation is quite concerning. I mean, not concerning. It's just the beginning. Let's put it like that. Like IoT industry. It's just at the beginning from security point of view. So we can see the world divided, split in 2, 50-50. Companies that does security officer in ICS that do threat modeling, and some that they don't. But the main reasons are there are no adequate tools for ICS world, lack of resources, and lack of expertise. How many security architects have you ever met from the ICS industry? You have security officers, you have incident responders eventually, SOC eventually, but not real security architects. You have engineers that design the plant, but they are another type of engineer. They have in mind at most safety, reliability, not security, OT security. So I continued investigating, and eventually I ended up in the SANS ICS forum community. And there I realized that more and more people started to think about doing threat modeling. The problem is that, as I mentioned before, there are no specific tools for ICS world, and there is not a very defined process. That's why I tried to put together those slides before to define a similar process that is working, is proved working in AppSec. We can just reuse that partially and tweak it to fit ICS needs. So here people is still asking, how do I do? How do I design a model? In AppSec, we use DFD, data flow diagrams, to design a model of our banking application. Can we reuse our 3D plant design that other engineers design? Can we use Visio? So I ended up creating a survey. This survey had very interesting results. One of the questions was, which tools are you using for doing threat modeling? Well, the answer was pretty funny, because most of these tools, as you can see, are not ICS related. The most used is Microsoft threat modeling tool. We will see later in the next slides what it is. And then Visio and Excel. And I cannot imagine the poor guys that are using PowerPoint for doing threat modeling, because it's even the worst. And then there are, in the fifth person, there are others. I will show you one of them, which is good for risk assessment. But let's start. So I named them the most widely used tools. I named them upon a spaghetti western movie: the good, the bad, and the ugly. So we'll start with the ugly, Excel. If you have ever done risk assessment, you know that Excel may be good for with all those cells, macros. It's very easy to define risk matrices and so on. But I want to see you doing threat modeling and identifying threats, categorizing them, and writing mitigations on Excel will be like mind-blowing. It's like code source review, high bleeding, or malware analysis, reverse engineering. Someone is tried with Visio. Visio is the most logic conclusion starting from a model perspective. You use your lovely stencils, or you download from vendors like Siemens, about the appliances they have and you're using your plan. And you create a very nice model interconnection. But that's it. It's just an image, right? You cannot action. You don't have action capabilities to point and click one device and set up properties and again automatically threats. I feel the pain. Which is the most valuable tool so far I've got in the survey that people is using is Microsoft Threat Modeling tool. It's a free tool developed by Microsoft, which, funny enough, it was developed for the secure SDLC process. So I'm using in AppSec world. So for doing threat modeling for products, software products. Though some of you was brave enough to use it for ICS. The problem is that may get very messy if you don't have a more specific follow a more specific strict approach, like the Purdy model. If instead of following the division of assets as levels as the Purdy model, you end up with something that is very complex and can create issues as well. So now we have seen the most used software by the ICS people that is still trying to do threat model. There is one tool that caught my attention, and someone is using for threat modeling, but I wanted to show you why it's not good. It's called CSAT, Cybersecurity Evaluation Tool. It's a tool developed by the Department of Homeland Security of the United States. It's very good for risk assessment, right? Because it gives you a recommendation from risk perspective. It provides a baseline for the cybersecurity posture. The problem is that it is not very good, doesn't fit the threat model idea, the threat model process. Why? Because it doesn't validate the accuracy of the threats that you find. It doesn't detect threats per se, technical threats. It detects possible risks. And then it cannot reuse, for example, 3 existing 3D models. You have your plant in 3D, right? Or isometric point of view, and so on. So it's good for risk assessment, but not very good for threat modeling. So just to recap slightly, what we have so far. ICS threat modeling is not fully implemented. There are a lot of uncertainties. How to do it systematically, how to scale it up, which tools to use. It's extremely time-consuming due to the reason above. So we need a better approach. And that's why I'm here, trying to spread more the word about threat model. Because if you look online about success cases of threat modeling in AppSec, you will see that, it's working. The idea is working. We just need to tweak the process from AppSec and fit ICS needs. So what we need? Ad hoc tools. That's one thing we need to work on that. And then a continuous threat modeling process. So in this case, I started to work on something called, yet another acronym, CATHAMA, Continuous Advanced Threat Hunting and Modeling Activity. So in software development, we have the so-called agile, recurring sprints, very fast-moving, that can produce quality results, right? We cannot go fully agile in ICS for tons of reasons. Though we can do continuous threat modeling. As I said at the beginning, it's very difficult that you are now in a design phase of a plan. Because most likely you already work on an existing plan. Maybe you have a plan to create a new plant in 5 years in another location, right? So there you can start do threat modeling in design phase. Otherwise, you need to use an existing plan. How it works, Katana? Of course, it's a work in progress. I'm working on a research paper for that. So it will be more complex and more defined. But I wanted to bring you here today just the initial key points of what Katana is. Katana is based on the Purdy model. So we have different division of assets, depending on where they are located and their function. It infers a continuous effort in hunting, analyzing, evaluating, prioritizing threats. And how we can do that, especially from risk rating point of view, we can use intel feeds. There are plenty of vendors, just one, Kaspersky, that provides intel feeds. Or yesterday was announced the vulnerability database, for example. We can use all this information or automated scanners if you are brave enough to run automated scanners all over your ICS infrastructure. So we can gather all this information, all this intel, to help ourselves to create and categorizing and rating threats. What's another concept I really liked of the ICS industry and generally the 3D technology. The concept called digital twin. Digital twin is a digital representation of your plant in 3D, which can be where it can be applied also the so-called 4D. I know it's a buzzword like time space shifting. But what we can do with that, we can do simulation. If we feed this 3D model with all those data streams from your sensors and your appliances or Intel feeds and so on, we are able to simulate what will happen if a specific attack will be triggered. So in this case, we have different points that can improve threat modeling in ICS. As I said, it's work in progress. Here is that survey I started. So if you want to add some more statistics to that, please. I will publish the results after a few days, probably. And, well, if you want to participate about the Kathama project, well, feel free to contact me. Probably I will open a Slack channel for that, because I see the potential. I see that it's successful in AppSec, and we can just improve it from ICS work. Thank you.